Section 6.3 involves operations with functions. If we let f and g represent any two functions, so for this example, f of x is 5x, g of x is x plus 2, and you can see them right here in the black. If we let f and g represent two functions, we can do different operations with those two functions. According to this rule, all I have to do to figure out a new function, h of x, would be to add f of x plus g of x. So I'm going to do that. I'm going to say h of x would be equal to f of x, and for me, that's 5x, plus g of x, which is x plus 2. Now all I have to do is combine like terms just to figure out my new function. 5x plus x gives me 6x. So my new function, h of x, equals 6x plus 2, according to the addition property. Next rule says, if I want to subtract them, I take f of x minus g of x. So I can do that. I can say h of x is going to be f of x, and for me that's 5x, minus g of x, x plus 2. Notice how I put parentheses around anytime I have an expression that's more than one term. Have to make sure you're subtracting the entire thing. Okay? All I'm doing here, guys, is I'm doing exactly what it tells me to do. In problems, you're going to be given f of x and g of x, and it's going to tell you to add them, subtract, multiply, divide. All you do is exactly what it says. Keep it very literal. Just be careful to put parentheses around when you are subtracting. Okay? So we distribute our negative. That gives us 5x minus x minus 2, which leaves me with 4x minus 2. So when you subtract f of x and g of x, you end up with 4x minus 2. Now we'll multiply. F of x times g of x. My f of x is 5x. My g of x is x plus 2. Here, all I'm going to do is distribute that 5x to the x, and then the x plus 2. 5x times x gives me 5x squared. 5x times 2, 10x. And we would, I know you guys are tempted to pull out the common terms. We wouldn't do that. We want to leave it multiplied. Last one tells me to divide. This one, and I'm going to write it up, well, I'll write it right here. This one tells me to take f of x and divide by g of x. Here, I can't really do anything. I don't have any radicals in the denominator. I don't have anything I can pull out and simplify. Do not be fooled and think that you can cancel that. Remember, we can't do that. You can only cancel x's if it was pulled out of the bottom. So there, we're done. Okay, so function operations, you're doing exactly what they tell you to do. They will define a function for you. All you have to do is add them, literally add them, subtract them, be careful of your parentheses and your negative, multiply and divide. And in the bottom here, it says the domain, remember we talked about all of the x values that are possible. The domain of h, the new function, needs to work for both f of x and g of x. Okay, so f of x and g of x really have no restrictions, but look at this division one here. When you are dividing now, we need to make sure that you don't have a 0 in the denominator. And if we had 2, or negative 2, we would have a 0. Don't worry so much about the domain. Focus on this stuff. Remember, domain talks about everything that x can be in the function. So here x can be anything, here x can be anything, but here x cannot be negative 2. So the domain for this function would be x is all real numbers. And remember, with domain we have that funky R we can make, except negative 2. We'll practice that more. Okay, now we'll practice those properties. Here, we're adding and subtracting them. We're just going to do one together and the other one I'll put the answer up there for you guys. Here, it wants me to take f of x and add g of x. These are our power functions because they are in that form, y equals some base to an exponent. So this tells me take f of x. My f of x is 4x to the 1/2. And add it to g of x. My g of x is negative 9x to the 1/2. Okay, remember last section, in order to add these power functions, those rational exponents, they need to match. Those are just like radicals. So they match. I have an x to the 1/2 and an x to the 1/2. We're in business. We can do it. So 4 minus 9 gives me negative 5x to the 1/2. You guys give b a try. Subtract f of x minus g of x. And then think about that domain. What can x be in a and b? Okay guys, so again for b, you're literally taking f of x and g of x and subtracting. Note my use of parentheses. That really helps keep track of those negatives. We still have matching x's. They have the same exponent, or rational exponent, or radical, right? Because it's the same thing. And we end up with 13x to the 1/2. Now the domain part can confuse students, but really it's not a big deal. Domain, remember, talks about all values of x that are possible. The domain of your original function, f of x, has to be a positive number. So the way we say that is x can be all non-negative real numbers. Think about it, guys. It's a radical. You don't want a negative number in there, otherwise you'll get an imaginary number. Same deal with g of x. So since f of x and g of x are the same, when you add them together, you still get the same domain. Okay guys, again, these are very literal functions. Let's do b, because b tends to be a little more difficult with the division. F of x, they're telling me, is 6x. G of x is x to the 3/4. Okay, we just talked last chapter. When you're simplifying like this, we have the same base, different exponents. We're going to put a 1 there. We're just going to subtract those exponents. 6 divided by, there's no number here, it's just going to be 6. Our base is an x, and we're going to subtract those exponents. 1 minus 3/4. When we subtract 1 minus 3/4, we actually get, remember, we can think of that as 4/4. That's the same as 1. 4/4 minus 3/4 gives me 1/4. You guys give A and then C a try. Think about what can x be for both domains. Then think about what they would be together.